I'm going to solve this problem using the problem-solving model, which is analyze, plan and solve, and justify. Wendy is using beads to make bracelets. She has 10 beads. She used 6 beads to make a bracelet for her friend. How many beads does she have now? So I know what you're thinking, wow, you chose a really hard problem for us to solve. But in all seriousness, I did choose an easier one just to walk you through the process of solving a problem using the problem-solving model. So the first step that we're going to do is analyze, and I have the question here. What information do I know? So without inferencing or putting your own thoughts on the problem, what do you know from it? So let's look at my data in this problem. So in the second sentence, I see that she has 10 beads. So I'm going to write that and analyze. 10 beads. And it is important to write what it is because from our story, it's 10 beads. You don't want to leave it 10 because that could be 10 anything, 10 cats, 10 elephants, 10 lampshades. So remember to write what it is from your problem. Okay, looking at my next sentence, it says she used 6 beads. So there's another piece of data. And I think it's important to add used. So I'm going to underline that too. I'm going to write that as well. Used 6 beads. Okay, going through my problem. That looks like all of our data. So I'm going to write what we're solving because this is a problem and it's asking us a specific question that we need to use our data to solve. So it says, how many beads does she have now? So I could put that whole sentence here, but to make it a little bit more friendlier, I'm going to make it a 2-sentence or 3-word sentence. Let's write beads now because that's what we're trying to find is how many beads she has now. Beads now. Okay, this is our focus. Now I'm going to go through our data to make sure all of this is important to solving the question because sometimes they'll add some extra information. I know to throw you off, so you just want to make sure that all the information that you have is important to solving this. So let's start here. Is knowing that she started with 10 beads important to solving her question is how many beads she has now? Yes, very important. Is knowing that she used 6 beads important to finding out how many beads she has now? Absolutely. So I'm going to check that off. So both of these pieces of data are important to solving our problem. So now that we've analyzed or really looked through our problem and made sense of it, now we can move to plan and solve. What is my plan to solve the problem? So I'm going to draw something new here. So it's going to look like this. Now, the reason I'm drawing this is because I want to remind myself of different ways that I could solve this problem. What are the possibilities? So in 4th grade, there are 4 different operations that you could use to solve a problem. And they are, you could add, you could probably guess the next one, you could subtract, you could multiply, or you could divide. So in 4th grade, we're going to be working with whole numbers. So with whole numbers, when you add 2 numbers together, it gets bigger. When you multiply 2 numbers, it gets bigger as well. So on this side, to remind myself on this side that it gets bigger, I'm going to draw an arrow that goes up. And then on the other side, I have subtraction. So when you subtract 2 numbers or you divide 2 numbers, it gets smaller. So on this side, I'm going to draw an arrow down. So that just gives me my possibilities of, hey, I could solve this problem in different ways, and I really want to make sure I'm selecting the right way to solve this problem. So now I want to go back to my data and think about this to make sure I choose the right one. So I start with 10 beads. So think about 10 beads, and then I'm using 6. So if you're using some, you're taking away from this pot. 1, 2, 3, 4, 5, 6. And then the beads I have now is here. So is my number getting bigger? Or is it getting smaller? My number is getting a lot smaller, so I'm not going to add, and I'm not going to multiply. So now I need to ask myself, am I taking away or subtracting, or am I dividing? Am I putting these in equal groups? So if I have 10 and I'm using 6, I'm taking away. So I should use subtraction. So my plan to solve this is to have 10 take away 6. So I'm going to write that here as an equation or a number sentence. 10 take away 6 equals blank. That's what I'm going to use. This is my plan. Now let's choose how we're going to solve this. So since this is a little bit of a smaller number, I'm just going to solve this using models or pictorial representations. So 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I'm going to subtract 6 or take away 6. 1, 2, 3, 4, 5, 6. And then what am I left with? I'm left with 1, 2, 3, 4. 4. So I think my answer to this problem is 4. Now, a lot of the times we feel like we're finished with this problem, but we have another step here, and it's justify. Now, justify is important because if you've done all this work, you want to make sure that you get this problem correct. And sometimes in justify, you'll feel really confident in circling like, hey, my answer to this problem. Or sometimes you'll realize, hey, that doesn't make sense, so I need to go back and make sure I get this problem right, see where I made a mistake. So now, how can I prove that this answer is right? So here I did, I used models. Now this time I'm going to use the standard way to subtract. And this may be new to some of you, so I'm going to go a little bit slower. So the way I use the standard way to subtract is I put 10, take away 6. Now I'm stacking these numbers, the bigger number on top and the smaller number on bottom, and I'm making sure they're in the right place value. And when I start subtracting like this, I start in my lowest place value, which is my ones place. So starting in my ones place, I have 0 ones, and I need to take away 6. If I have 0, can I take away 6? No, you can't. So what you're going to do is go next door to your tens place, and you have 1 there. So you're going to take that away. So think about a 10 rod. When you move it to your ones place, how many ones does a 10 rod make? A 10 rod makes 10 ones. So this decomposes or breaks up into 10 ones. Now we can subtract in our ones place. 10 take away 6 equals 4. So that is one way I could justify my answer, or I could have done the reverse operation. So like this, so 10 minus 6 equals 4. I could also say, hey, if I add these together, I'll get back what I started with. So 4 plus 6 equals 10. So kind of like fact families. And that's just another way that you could have proved that this problem was correct. Now, I want us to take a step back and look at all of this work I've shown. Was all of this work important or necessary in order to solve our problem to make sure that we got it correct? Yeah, I know this problem was a little bit easier, but think about when problems get more complicated or there's more information or things like that. You can see how this is useful to making sure that you're doing the right thing and you're making sure that you're getting it right and checking yourself as well.